Hello, everyone. Welcome to our webinar. This session will be recorded for the people who are not able to attend at this time, but definitely want to see the answers to our questions. Feel free to address questions during the presentation in the chat, or just note them down for our Q&A section at the end of the presentation. This webinar will continue our research started in our previous webinar for using GenAI in supporting modernization, as well as simulating developer day-to-day activities. In our previous webinar, we looked on how GenAI can speed up the development process by being able to generate code for both backend and frontend, even by a developer with no frontend in-depth knowledge. Today, we will make a step forward and we'll try to add tests to the previous generated classes, and we'll discover how useful the AI is in doing this. To start, I'm Mihai Nagoe, the operations manager at Wayfair. I have a background in software development, specializing in progress open edge and related technologies. I've been in this field for over 18 years, being involved in the full life cycle of a software project, working on everything from coding to leading teams and managing projects, mainly focused on modernizing existing applications. With me is Virgil, who you met on our last webinar. I'll let him introduce himself.
Hi everyone, my name is Virgil. I'm a tech enthusiast with over 15 years of experience, specializing in goal-driven strategies that deliver real impact. I had the privilege of leading exciting projects across industries like healthcare, automotive, finance, constantly finding creative solutions to complex challenges, always looking to make a meaningful difference while enjoying the journey.
About Wayfair, since our founding in 2012, we have accumulated over 12 years of expertise in delivering dependable services and solutions. Through steady organic growth, our team now comprises of more than 100 skilled professionals. Over the years, we have cultivated strong and enduring partnerships, with some exceeding a decade. Our longest standing collaboration, spanning over 10 years, speaks to the trust and the value we constantly offer. To date, we have worked with more than 50 satisfied clients, 19 of whom continue to actively collaborate with us on ongoing projects, reflecting our dedication to building lasting relationships. Our services include modernization, maintenance and support, quality assurance, consultancy, and project delivery. Our talented development team stands out due to our ability to attract top graduates from leading computer science universities, blending their fresh perspectives with deep knowledge and expertise of our experienced professionals. Our primary technologies center on progress open edge and web technologies. A significant portion of our project focuses on modernizing from Progress UI to web technologies, with Angular and React being the most favored options. We have expertise in developing desktop, web, and mobile applications using various frameworks, including low-code, no-code solutions across different environments. Additionally, we offer UI/UX design services, support for DevOps, including continuous integration and continuous delivery implementations, and both manual and automated testing services. We're located in Cluj-Napoca, the major city in Transylvania, northwest part of Romania. As an interesting fact about Cluj-Napoca, the major university, Babeș-Bolyai, is ranked first in Romania and 14th in Eastern Europe, according to topuniversities.com. It is also the oldest higher education institution in Romania, with its roots dating back to 1581, and currently has an academic community of over 55,000 persons. For today's webinar, we'll start with a short recap on modernization and where quality assurance and quality control take a part of the project lifecycle. Then we'll dive into quality assurance, quality control, specifically on software testing, some frameworks used in the testing process, how GenAI supports this activity, the tools and the benefits of this, and we will have a demo on using these tools in a dev environment. We'll try to create a developer's hard day at work once the development is ready, with GenAI tools available to support his activities in making sure the right quality of the code is delivered. In the end, we'll draw some conclusions based on our experience using these tools and check on some challenges we had. Software modernization is the process of updating or transforming current systems to improve performance, usability, security, and maintainability. The scope is to make the current systems compatible with modern technologies and user expectations, and most of the times the modernization process is a strategic decision of the business to grow in the digital era. Software development lifecycle is a structured process that is used to design, develop, and test good quality software. The software development lifecycle defines a method for improving the quality of software and the overall development process. In our experience, quality code needs to have three key qualities: clarity, reliability, maintainability. Well-tested code that follows the best practices and coding conventions of the programming language the application is being written in is crucial for long-term success and reliability. Testing is an integrated part of the cycle, and we will see forward its importance. First, start with the difference between quality assurance and quality control. Quality management ensures that the organization, product, or service is constantly pursuing excellence. Both quality assurance and quality control concepts are part of the quality management. The terms QA and QC are often used interchangeably, even though these two terms are similar. There are some differences between the two concepts. Quality assurance involves in process-oriented activities. It ensures the prevention of defects in the process used to make software applications. Quality control involves in product-oriented activities. It executes the program or code to identify the defects of the application. Testing in software engineering is a process of analyzing and examining a software product or system to determine whether it satisfies or fails to satisfy established conditions, such as defects. The testing process evaluates the software products for bugs or errors in order to evaluate its reliability, security, and performance. Testing helps us find and fix these problems before real users see them. This is a question to summarize. Would you fly a brand new airplane for the first time? Well, if the answer is no, then let's see which are the benefits of software testing. First, cost effectiveness. It is better to start testing earlier and introduce it in every phase of the software development lifecycle, and regular testing is needed to ensure that the application is developed as per requirement. Then we have customer satisfaction, security. This is probably the most sensitive and vulnerable part of testing. Testing types like penetration testing and security testing helps in product security. And we have increased product quality. Software testing falls into a few main categories. We have functional testing, checks if the software works as it should based on the specified requirements, as example, unit, integration system, and smoke testing. Non-functional testing checks things like performance, scalability, and usability. Maintenance testing, testing updates and changes to the software, including regression testing to ensure nothing breaks. Testing can also be done in two ways. Manual testing, testing the software by hand like a user to find bugs, and automation testing using scripts and tools to automatically test the software, especially for repeated tests like regression, performance, and load testing. It's faster, more accurate, and saves money in the long run. Here's a summary of software testing best practices. Test new versions frequently in real-world scenarios. Involve users to get feedback, which will guide the development and testing. simulate unavailable services for early testing, use reports and dashboards to communicate results, always perform regression testing after changes, have testers, not programmers, create test cases as developers may be biased towards their code, and break the tests into smaller parts for efficiency. Next, we will look to some testing frameworks. Testing frameworks are essential tools that provide a structured environment for developing and executing tests. There are several types of testing frameworks, each serving different purposes. Some common types include unit testing frameworks. These are designed for testing individual components or functions in isolation, like JUnit or ABLUnit. End-to-end testing frameworks, which simulate real user scenarios to test the entire application flow. Performance testing frameworks focus on testing the performance, scalability, and the stability of the application. And here we have tools like JMeter, Load Runner, and so on. In our preparation, we used one framework for the backend and one for the frontend. For OpenEdge backend, there are several options like ABLUnit, OAUnit, Progress Testing Framework. We chose for the demo to use ABLUnit because of the native integration in OpenEdge Developer Studio and easy integration in VS Code. It's easy to set up for ABL developers and is familiar for OpenEdge developers. Follows ABL project structure for organizing tests. For the front end, we looked over 3 of the most popular tools for browser automation and UI testing, like Cypress, Playwright, and Selenium WebDriver. Each of these tools has its strengths and is suited for different test needs. We opted for the demo for Cypress because it runs inside the browser itself, eliminates flakiness caused by network delays and external dependencies, and makes test scripts cleaner and more maintainable. It has automatic waiting, it's easy to install with npm, and has real-time reloading. Looking on our agenda, our next subject is on GenAI usage with testing. This is a snapshot from the previous webinar with the Gardner model of hype cycle for AI, and we'll see how this evolved since then. I'll hand over now to Virgil, who will explore the GenAI with the software testing part.
Okay, thank you, Mihai. Can you hear me? Yeah, I suppose.
Yeah, we can hear you.
Okay, so as you can see here in the latest Gartner's hype cycle for AI, generative AI is moving from peak of impact expectation to trough disillusionment, where interest wanes as experiments and implementation fail to deliver. We'll see if this happened in our demo. Okay, let's see what happened between October last year and March this year. We noticed quite some changes in major areas, how the tools and models are operating. We noticed an improvement in accuracy and cost efficiency. OpenAI models have significantly enhanced accuracy, achieving 83% in math competition compared to the previous models. Other changes in advanced reasoning and contextual understanding using multi-step problem solving. AI models now exhibit advanced reasoning, solving complex problems through multiple steps. We see 2 paradigms that are raising right now, reasoning and action, where instruction of agents to think and plan after each action and tools response, deciding which tools to use next, and reasoning without observation, which, unlike React, eliminates dependencies on tools output for action planning. Agents plan upfront here, avoiding redundant tool usage by anticipating necessary tools upon receiving the initial prompt. A third major difference is the update customized GenAI application, specifically agentic AI, where autonomous AI agents are expected to become more prevalent, capable of performing tasks independently. And here we see five main agent types that are starting to be used. Simple reflex agents. This is the most basic form, responding to current perceptions without memory or interaction with other agents. They are programmed to perform actions when specific conditions are met. Second, model-based reflex agents that are currently utilized and use perception and memory to maintain an internal world model. Goal-based agents maintain an internal world model while chasing predefined goals. Utility-based agents, which are optimized and have actions not just to achieve the goals, but also to maximize reward or utility. And learning agents that possesses all the capabilities of other agents, but uniquely adapt by learning over time. Okay, so how GenAI impacts software testing? Automatic test generation, we see four major directions. Automatic test generation, create diverse test scenario, including edge cases, reduces manual effort and improves test cases. Test data generation can generate realistic and complex test data from various scenarios. Test maintenance automatically updates tests as software evolves. And the last one, the code analysis and bug detection, identify potential issues before they raise. Integrating generative AI into software testing offers numerous benefits while improving efficiency and effectiveness. Increasing the efficiency, AI-driven automation on test case creation saves testers times, allowing them to focus on more complex tasks. Expansive test coverage, expanded test coverage by generating diverse test scenarios. AI ensures broader software testing, reducing the risk of the undetected bugs. It can also identify gaps in existing test cases and suggest additional tests for edge cases and rare scenarios. Early bug detection. AI tools can help identify potential issues early in development, making it easy and more cost-effective to resolve them before release. Cost reduction by streamlining testing and minimizing manual efforts. AI lower overall testing expenses. Predictive analytics is another benefit, leveraging historical data. AI can predict highly risk areas in software, enable QA team to prioritize testing where it's most needed. Continuous learning. AI continuously improves by learning from past testing experience, leading to more effective test cases and predictions over time. And improve collaboration. AI facilitates better communication between QA and development team by providing actionable insight, ensuring consistent software quality through the development lifecycle. Well, GenAI brings many benefits, as we saw, to software testing. Its implementation comes with some challenges, such as complex setup. Deploying GenAI system requires significant resources, including specialized expertise in infrastructure, data quality dependencies. AI performance relies on highly quality training data. Inaccurate or biased data can lead to flawed test cases and unreliable application. Integration challenges, incorporating generative AI into existing testing frameworks may require modifications to current processes and tools, adding more complexity. Algorithm dependencies, relying too much on AI-generated tests can lead to blind spots. We'll see it later as AI not fully understand all software context or nuances without human oversight. And high initial cost, although AI can lower long-term expenses, the upfront investment in technology and training can be substantially for some organizations. GenAI is transforming software testing by enhancing efficiency and accuracy in test generation, documentation, and various testing processes. Test case generation, there are some tools right now like Test Rigor or functionalized test agents that leverage machine learning to create test cases based on user prompts, application behavior, and interactions. This significantly reduced the effort and time required for test coverage, documentation generation. The AI-driven tools like Notion AI can automatically generate technical documentation by analyzing requirements and test results, producing clear, concise, and good documentation. Code assistance, here we have some platforms like GitHub Copilot and Claude, assisting in writing, refining test automation code, accelerating development while ensuring tests align with applications requirement. Cross-browser testing, tools like Browser Stack generate scripts to validate web application across multiple browsers and environments, ensuring a consistent user experience. Web and mobile testing, GenAI supports end-to-end testing for web and mobile applications. Apply tools use AI-driven visual testing to detect UI inconsistency across different devices and screens. We will have a demo today for the application. We started our last webinar and on which we will create tests using GenAI to support us in this activity. We will try to see if GenAI is ready to improve the quality of the application and simplify the life of a developer who need to implement test cases. Our approach, so we split it in two, backend and frontend. For the backend test, we wanted to find the answer to some questions. How accurate are the tools right now? How much coverage does it provide? Can we increase the coverage of an existing unit test class? Is writing unit test easier, faster, or not? For the backend, we use GitHub Copilot, which is integrated in Visual Studio Code through an extension. Can be used as a chat, similar to ChatGPT or inline. The chat is better as it saves the chat history. We can share it using the import-export function that Copilot provides. The model uses Copilot. Model used by Copilot is GPT 4.0. It has unlimited prompts allowed. For references, we can specify there is specific functionality where we can specify add workspace or to look the entire project, or we can use a specific file to set it to the context that will make Copilot use the entire file as a reference with #file. Okay. AI is a powerful tool, but the key is knowing how to use it. For frontend, we use Cursor, and we went for the premium version, which is a paid one. The main difference is the usage of Claude 3.7 instead of GPT 4.0 mini, and there are some perks which come with this selection. In Cursor, different settings and features must be selected for the best results. The chat feature helps with understanding the code, while Composer is used for code generation. We will see it in our demo. Claude 3.7 is a premium model optimized for coding, while GPT 4.0 mini takes over once the premium access is finished. Requires specific details, not that advanced, and may sometimes produce code with compilation errors. This image compares AI models across tasks like reasoning, coding, multilingual, and math. Grok 3 Beta and Claude 3.7, this still performs strongest overall. Okay, so let's do a demo. I will share my screen. Okay. Okay, this is the screen. Okay. So this is the screen. Okay, this is the Visual Studio Code. So what we have here, we set up the project. The previous project that we built until now, we set it in Visual Studio Code. We configure it. What we have. So we have the extensions, ABL test runner. This we wanted to run it directly from Visual Studio Code. We have the Copilot extension. There are two, GitHub Copilot and GitHub Copilot Chat. And we have from Riverside the language server for OpenIJBL that we installed over it. What we have as structure of the code, we have a simple structure. So I'm going back to resources. So we have the code is split by folders per entity. So we have an SE. This is the service interface that we are exposing functionality from the entity. So as we can see here, we're exporting basic functionality from our entity that we generated in the previous webinar. So we have the CRUD operations over it, and that will call the entity class. We call further to the data access that will check, that will do the actually operations. We have a data set definition and a timetable, simple timetable for department in this case, and also we have for employee the same structure. Everything that we are seeing here were generated in our previous webinar. Okay, so let's do the test, right? So for this one, we trained. So let's see. Let's talk about the one thing that I want to show before. So we have here, we can export and import chat history. So this is one way to transfer the knowledge, the internal knowledge that we are having on one workstation to another. So we can import it and export it from one workstation to another. I already have imported it. By importing, you just it's exporting a JSON with everything that was prompted before, so we have a local knowledge database with what happened before. I already imported that one, so we want to generate an employee BE test. So for this one, we will use a simple prompt like create a unit test. I don't know if you can see it. Create a unit test class for employee BE. Class similar to the test classes that we have. So we notice that having an example or having a standard common for as a software guidelines for every developer that will respect. Now we can say that, hey, you have similar structure. Have a look over the files that we already have provided, and then create me some test data. This is for mocking everything for the required data for the testing. Now, what's happening behind it? Copilot will check the entire file that we have provided, employee BE. We will check in the folder with the main source test, where we have all the tests that we already have right now. We'll read the employee DA, the data set, and timetable, and we'll generate the unit test for employee B. Let's see what we generated. So we have the dataset definition. We have here a reference to the entity. We have the setup method. Define. We have the mock data. We have a tear down setup, and we have the test for creation of the data, reading of the data, update. Let's see. So basically for all operations that are defined in our entity, and because our prompts involves also generating the test data, our last statement in our prompt, we have also the test data JSON file generated. So for this, I'll copy it. I should put it in the right place. Here. Now what I have done, I took the output of the prompt and I will run it. Make sure the outcome is valid. Okay. As we can see, the test passed, and we have 100% coverage of all the methods from the employee B test. Okay. Now, if what we wanted to answer to one of the second question was, hey, can we increase the coverage? So let's say like we have a unit test class. So can we increase it? So for this one, first we wanted to see if we have everything covered. So what we have in employee BE. So we'll open department BE, department BE. Okay, we have create, update, delete, read, but the test that we are having here, test read all department, test read, test create. We're missing some test. For this one, we can check. Okay, I will go here to make sure we have it in context. Okay. Okay. Just put a prompt. What is the coverage? I know if you can see the prompt. What is the coverage of file department BE? As I specified earlier, with hashtag file, we specified the file that we wanted to take into consideration. As we can see here, the following methods of department BE are not covered by the current test in department BE UT. And what's happening next? At this version of Copilot is generating my missing test. So as we noticed, it already noticed that update data, delete data, they're not covered by any method. Any test in my test class. So it generated the test, the missing one. I just copy paste it, going here. And let's see what's going on. Okay. And now we see that one of the tests is failing. So this was also one of our outcomes. What we have here is that the coverage, the Copilot generated all the necessary methods that weren't covered, and it already generated the missing ones. So the coverage should reach 100%. But what we are seeing right now for the this test that is failing is that it tries to understand and replicate the other test that it has in its model, but sometimes it's failing to generate compiling running test. So, but this is useful to know that we already have the mocked, so we already have the structure. So here now, as a developer, we have to check, hey, why this things failed. Okay, now we're gonna switch to the front-end part. So here for the backend, we try to generate unit tests for the OpenEdge code using directly Copilot out of the box with a pre-trained, pre-prepared chat history where we put a lot of prompts there to have it up and running. What helped us for the backend part is that we had in our test folder, we started to build 5 to 7 unit tests that try to cover most of the cases for the OpenEdge part. And this fact that we already exceed the 1 of 2 tests when we have multiple tests in our project, and in the prompt, we specify the resources from where he can look to have a grasp of how the unit test should look like. The better results we get as we have as many tests available. Okay, I will switch to E2E part. For E2E, we have to open a different tool because we use Cursor. Okay, now Cursor is opening. For this, for setting it up, we need two things. One, to start our server. So let's see. Okay, that's good. The server started. Meanwhile, between it's doing its starting point, it's better to show you the services that we already have. Okay, so we have exposed update data, create, read all for the for employee, employee with read with employee number as parameter, delete data, and for department we have also read all, update, create, read with parameter and delete. Okay, I will relog into the application. So what we're seeing here is the first screen that we generated in our last webinar. So we have a simple maintenance screen with search, edit functionality, okay, and delete that we generated in our previous webinar. Okay, here the same. So we can search, we can create. I'll put here debt 900. Okay, 9,001 and delete. Okay, back to Cursor. So we have the application up and running. We have these two screens that we already generated. What we want to accomplish, we want to generate end-to-end testing for these two screens with all the CRUD operations to test them directly using only prompts available and functionality available in Cursor. So for this one, so we already opened the application. I'm going to start a Cypress. We already have it configured. Configuring is 2-minute step, but yeah, to have it up and running, I pre-configure it. Okay, now it's starting starting Cypress. I will choose E2E testing. Now it's reading the configuration file. I'm going to start E2E. So this is opening its own browser. We have here some test category, login, organization test, and user list. Okay, now I'm going back to Cursor. For this one, I need to do 2 steps. I want to generate for department. I will open Composer part, and now I will select it for the context. I will select the template. We have the possibility to choose a different model that we're running on. I will choose Cloud 3.7 Sonnet. This is the latest and is suitable for code generation. And the prompt. The prompt says like this. I don't know if you guys are seeing. Use prompt template from my template file with department as parameter. I will go to here to see it. So the prompt says generate a test similar with the existing. Here we put on purpose a typo to see if it can identify the keyword that is important. But for entity, entity we specified as a parameter that performs CRUD on entity and entity service and the field from types.ts. Order of the fields, it is important because we notice that Cypress takes the order alphabetically, and in how we generated the screens, we didn't have them alphabetically. We specified we don't need to add all the fields, only required ones, and clear the pre-filled values before trying to add new data. Do not, and the rest is some restrictions. Do not accept empty string and only date and not days left, and where to find the endpoint of the APIs. And we provide a simple example if it doesn't find in the project anything. Okay. What happens? Meanwhile, we can look in what are the steps that were done. First, tries to understand the existing structure and gather all the informations for my department entity. It search for department service to check the endpoint, look for the types, looked in the main page, department page, and then it looked in the test that we provided. Then started to read the endpoints, the desktop page. Desktop page is being to be split in two. Then look to the create form dialog. This is the edit update page, and read again the test page. After you're gonna accept the test, I accept the changes that were generated. I'm going back to Cypress. And rerun the test that we already have. Okay, so I'm looking to see if it's finished. Now it's creating a new record, did an update, and now I'll delete it. If I'm gonna rerun it because we missed the initial part, it will try to log in and go to department page, and here are the steps for creating, updating, and deleting the page itself, the record. Sorry. Okay. The same thing if we want to generate, because we use the template, so we noticed that we can have really large prompts. For example, we reach at some point trying to generate a functional working test. We reached at some point that we had like 2 pages of context setting for the prompting, and we said, hey, it should be an easier way to do this. So we discovered that we can use templates itself. So this is the template that we are using. I will try to go to here, E to E. I want to use the template, use the same prompt that we use for department, the same template, but we use a different parameter for it. Meanwhile, what's happening behind it? Oh, not this one. We start to analyze all the information that we provide. High load. Load.
Yes.
Now we notice that there are some periods where there are high demand for some models. What we did when we encountered this one, we switched the model. So as I show you from here, we can switch from different models to use it from prompt. It seems that right now, because Cloud 3.7 was released last week, I think, everyone is trying to see how it's working, and we have a recommendation for to use a default one or a one that which is one 3.7, 3.5. Now let's see if I go into its recommendation. Do it again, the prompt. Okay, seems that yeah. Okay, seems that my existing text is matching with what needs to be generated. So this is because this morning, here is the important thing. So because I already generated with 3.7 this morning, and I switched to a different model, the new model generates exactly the same thing, and it doesn't generate it anymore. So we can test it directly, this one. Okay, let's see.
Is this data coming from the mockup data?
Yeah, good point. I'm going to show you what was generated. So this is how an E2E test looks like in Cypress. So we have some CRUD operations, some specification for security. We have initial data defined that are required for mocking some, getting the employees. In order to perform the CRUD, everything should happen inside the loop, inside login. So we need to make sure that we are logged into our server. And from here, we are switching between different operations. So first thing first, what's highlighted is the login part. We're saying, hey, wait for that one. In order to create, we have also a second set of data for mocking the creation of a new record. Here we try to, using post to on employee, we create an employee. Then we check if after it's updated, so we're gonna do an update and do then filling the form with all the information that was generated by Cursor itself. So it's adding all the fields that we saw on the screen. It's waiting for creation for the update, and then it's setting all the data. For the update, we wanted to change the position that was initially developer, and the address we change it from, so the position from senior from the developer to senior manager, and it has a new address. Then we put up an update request. We got an intercept was returned, getting the employee after the update, and all the checks that are behind it. So everything was generated in one place. I think we missed this one. I was running it and I switched to code. So it's doing the login. Now it's filling with the data that is the model generated it. So it's filling everything that was generated there. It's living in Chicago, state, Illinois, postal code, department. Okay, filling all the fields. And after it's gonna fill it, all the operations will be tested. So now it's changed the position and address. And after update the deletion to make sure that all my CRUD operations are working. Okay, pretty much this was the demo for today, generating the unit test and E2E for with Cypress and unit test with Copilot. I'm gonna stop sharing my.
Okay, let's go to some conclusions.
Okay, so right now we saw the output of our research, and now we will draw some our own conclusions from our experience trying to do it. we have some overall observation for the backend. How accurate it is can get very accurate with training, as we noticed in I think department unit test. We noticed that the skeleton was generated correctly. Only one method failed. This is a huge improvement since October last year, because there we had only the skeleton without actually branch testing and actually doing in-depth testing of those methods. The generated codes needs little to no refinement. Yeah, this is the example with the failing part. How much coverage does it provide? The generated test can cover the entire code. It can generate test methods for success and failure scenarios. We noticed an improvement with the branch testing. Can improve coverage of existing unit tests, and this was something that surprised us. Can it make writing unit tests easier, faster or not? Yes. It can make writing unit tests both easier and faster. Can provide a complete and functional unit test class using one prompt, a simple prompt. We can have generic templates that we can use and have them used across the project. However, it needs a close review and correction from a developer, from a human being, to have a look what's actually generated and if it makes sense to be there. The more prompts that we give to the model, the better it becomes. So this is part of having it trained based on the context of its local context. On the front-end part, AI-generated prompts provides a good starting point, but often requires manual and refinement for correctness. What we noticed here is if we don't have a standard, or some developers from the team are not respecting the standard, the coding standards from the project, it's hard for a tool to generate you a good output. So if all the developers will respect a specific standard that should be defined at the beginning of the project, or on a specific project, then the output will become better, and the required changes, the amount of required changes is not that big. Accuracy improves with well-structured prompts and iterative refinements to address missing details. This is something that we need to specify where to find stuff, because if we don't respect a standard, every developer will try to go beyond the standard itself. Then we need to do multiple steps of refining the results. How much coverage does it provide? We noticed that for Cypress, using Cypress, we have it covers fully covers the basic CRUD operations for each entity, ensures test aligned with existing formats and maintain consistency. However, edge cases and failure handling are not included unless specified in prompt. So for E2E, we had, in order to have everything in our template, we had large prompts that we used as a template. As we currently, I show you the simplest part, but if we want to have edge cases and failure handling, we need to extend the prompt to have those in the context. Can AI make writing E2E test easier? Significantly reduce manual effort by generating structured with minimal input. The template-based approach that we went through improved efficiency and ensures consistency across multiple entities. Still, human validation remains essential to refine logic and handle non-standard cases. So for a standard structured project that most of the things fit in the same structure, it's easier to use a model with a prompt. with a prompt, with a template. But in the moment that we have edge cases, there we need to have specific tests written, and the tool support us only with the basics.
Okay, thank you for answering some of the questions. Let's see if there are other questions for Virgil or for the research we did. Let's see. I have one question. What were the key challenges you faced and how did you overcome them?
So key challenges. So we started with an assumption. So hey, first thing first, how you get started, how do you make the setup? So this was our first challenge. So how we do the setup for them to make sure they work. This one we passed it really fast because we found a lot of trainings. There are some trainings available also for GitHub Copilot and Cursor. Then we encounter another one, the data quality. So we noticed that we started with we had only one test, one unit test, and one E2E on the front end. And we noticed that we need more data. So we need more examples from where it can learn. So here we extended, we reached, I think we have 7 in total, 7 full unit tests and 7 E2E full. And this was the major ones. Then integrating everything, integration with Cypress. This was due to the installation and how to configure it. But this one we managed that we overthinked that one with the Cypress.
Okay, hope this answered the question. For front end, what were the main differences you noticed between premium version and free one?
We noticed 2 things. One is the limited. We reached the limit of the free. 1 second. We reached the limit of the free available request, and then we decided to, hey, in order to have everything work in one place, we need to go with the premium one. As we saw together, also with the premium one, because we have a premium account here. It doesn't guarantee that your prompt will be fulfilled. We used Sonnet 3.7 and their server didn't respond with the prompt. So difference between free and premium is that you have a limit in the number of requests that get fulfilled with specific model.
Okay, thank you, Virgil. Well, if we don't have any other questions, I hope the information presented was useful and answered some of your questions. If you think GenAI is something you want to use in your projects or want to start the investigation on it, feel free to contact us by mail, webpage, or social media. Thank you very much for joining our webinar. Have a great day and see you on our next webinar.
Thank you.
Thank you. Bye-bye.
Thank you. Well done.
Bye.